Alright, so here I am in Blender, and Blender is the main application I use for all modeling, no matter what. I used to use Maya all the time. I teach Maya still, but when nobody's looking, I always use Blender because Blender is so much faster than Maya, and that's no lie. It's the fact that you have everything so hotkey driven that everything's at your disposal. The system, the GUI on this used to suck really bad, but they've done a really good job of turning this software packet around. And if you're used to Maya, you do have a nice little user preferences, and under input you can choose Maya as the way of navigating around. I do this anyway because, you know, when I teach Blender, I want to make it so they could easily hop into Maya and still survive. This is a great way to do it. Teach Blender, then Maya is very easy to learn. But if you teach Maya, Blender's pretty hard to learn, if you ever go to Maya again after using Blender. Alright, so if you hit N on the keyboard, you get the dimensions. So everything's in millimeters, and obviously you would have to go through a little bit of a training seminar if you're in my class before you ran the 3D printer on general interface and general modeling skills. So the only thing I didn't cover too much was the dimensions and how millimeters match up to things. Millimeters, amazing form of measurement. No wonder students have a hard time at an early on education with the idea of building stuff in America, because really our form of measurement in America is just horrible compared to millimeters, centimeters, meters. So that's no lie. You can ask anybody that actually builds or makes, they will totally support millimeters every day. So that being said, we need to make a really thin cube. Well, what's really thin in millimeters? 0.3 is pretty freaking thin. Okay, but that doesn't look thin, right? It is. And then we're going to have to make some kind of square, and the platter is 180 millimeters all the way around. That's a good buildable size. So 180 millimeters. We're going to go a little bit less than that. We're going to say 90 millimeters in Y and X. So now I have this really big, what seems to be big, very flat cube. Okay. So as you're going through here, things, let's say it was 120 millimeters. Well, that looks really huge in Blender. Here's what happens if you hit N and you look down. There's a clip end. If it gets too big as a part is concerned, you can make the clip end go further, and that way you can see more of it without it clipping out. So I can zoom way out now. See how it's clipping into the background? Well, if I expand this, I get more buildable area. Okay, good. Let's go File, Export, Still. And I'll export this into my desktop, and I'll put it right with all my software. I'll make a new directory and call it Stills. Good to keep organized. Trust me when I say that. I'll call this the level cube. That's it. Now we have to slice it. Okay, well, in our software, we have a program called Slicer. Again, if you're in the lab, my lab, I'll have to show you where this is at in the Linux world. But if you got my build, you'll also have the software. And there's a video in the playlist that tells you where to get this software. So Slicer. Later on we'll have a couple videos on how to set Slicer up, but I have a load configuration file called production machine that you're going to be using within the lab. And if it's the kind with the Bushido nozzle, you're going to be using generation 4. So check with me on what INI file that you're going to be using within the lab. There's only a couple. So this generally states that, you know, I have an extruder, it's 0.5 millimeters, and my filament's 1.8. Even though it's 1.74, I like to increase that by a little bit. It makes a better part. I got the temperature of the melting point of the plastic and the bed, and the first initial contact with the bed temperature, and then the bed temperature itself. So this file is very important. There's no doubt about it. And it's tailored to the machine. So I couldn't say, take this, give it to George, who has a different machine, and run it. Now, if you make all your builds the same, though, it will work. But, you know, if somebody had a MakerBot, you couldn't use this on a MakerBot or a Replicator or any of those other things. You would have to have the build that is very specific to this. Alright, and what I can do here is hit add, or I can drag the part in. Linux likes the dragging of the part, so let me just do that real quick. Desktop, stills, click and drag. Okay, there we go. Got our part. So make sure your printer settings are here, and then I can export the G-code. And I'll export it right to the same. There we go. So now I have the G-code. And G-code is just a level of instructions. You can actually open it with Notepad if you wanted to and look at it. Just a series of commands that the printer understands. The first initial line right here, these are all, you know, what the settings are of your machine, and then it runs through like starting bed temperature and things like that. We'll get into those weird things later. Alright, now I can go back to Pronterface under print run, and I could load that. So where was that at? Printer run, print setup, print software copy, stills, and there is my G-code. You can see G-code. You can also open stills within print run. Don't do that. Always slice using Slicer. Always use Slicer externally, in my humble opinion. It works a lot better. Okay, so where is it at? If you double click here and you hold shift wheel mouse, you'll see that you'll have a start. And this is only 3 layers high. Also, you'll get an understanding that under the Z-axis, the print goes from 0.28 to 0.56. So that's roughly 1 swipe of, or 2 swipes of the head, and then it'll stop. I'm going to warm the machine up. So, set. And you can also warm the bed up. I usually generally set it to 60, set, and start warming that up. Now if you wanted, you can go walk away before you hit print. I like warming up the machine a little bit before I hit print. It just runs a little quicker, and you have more control. So watch these numbers. They're very important. It shouldn't go over 230 degrees. If it does, it goes to 232, 235. That's fine. But it'll cap off at 240, and then it will shut off and go crashing back down if it gets to 240. Very rare that happens. And the bed, if you ever see that go past 85, in my humble opinion, don't let it do it. You can get it to 130 degrees Celsius, but it's so unneeded and such a wasteful thing of energy. So what we're going to do while this warms up, we're going to jump back into my on location. We're going to raise that bed up just a little bit, or raise the head away from the bed. So I'm going to hit 10. Just like that. That will allow me to do is now pull the bed forward just a little bit and butter it. Okay. Now this is going to get hot, so what I usually do is grab the binder clip and pull it forward. The binder clips don't get hot. Sandpaper. If you're getting a new piece of glass, you'll have to coat it with a catalyst. This way you don't have to go all the way up to 130 degrees Celsius and have your part stick. Remember, electric bills are important, right? Okay, what I like to use as a catalyst, hairspray. Yep, I know, it's weird, right? I use Tresemme Level 5 Freeze Hold Purple. You can use any, really. Hairspray is hairspray. Watch out for the ones with vitamins in them, though. The vitamins could cause it to have like a little bit of a slack. Don't breathe this in. You know what I mean? It's one of the things that you spray it lightly, it should be good to go. Just like that. All coated. And you can kind of go like that, and you can feel that it's already dry because the bed has been heated up while you were doing that. It's not going to catch fire, blow up. It's not going to do any of those weird things that you think it might do. It's hairspray. There's no open flame here. And it's only at like 70 degrees Celsius by the time you get over there. I would say at 240 degrees Celsius, yeah, you might want to not do that. Okay. So, let's go back to print run. Yep, everything's all good. I can hit print. And you'll see a series of things that's going to happen. First off, the bed is going to reach a new temperature. And the new temperature is stated within Slicer. That temperature is 75. And I know I said 80, but again, I like to keep this as lean as possible and still have it work, just for energy conserving reasons. You run a 3D printer for like 5 hours, and you tell me that your electric bill doesn't raise. Okay, I'm going to get on the other side of this thing because I am right-handed. And this is a leveling cube for a reason. What it allows me to do is first see if it's level. And as it's going around, I can kind of flick this every once in a while to get even more level until I see a steady stream of whatever color filament that you have. So this end needs to come down just a little bit. That looks good. And I should see a nice purple bead. Be careful, this thing is in motion. That's why these things are so big, that I can get in here and touch this without getting crimped in between layers. This is glass. It's got a sharp edge, but what I do, I grind mine down so it's not sharp anymore. This has a pretty good torque on it, though. You don't want to get your fingers like in here or anything like that. Generally, it's a really safe machine. Okay, now what I'm looking for is consistency of color. Oh. Okay, let me zoom in. See that color purple? I want that color purple to be throughout the whole print. I'm also looking at how straight the lines are that's going from corner to corner. Let me see if I could raise this camera up to see what I'm seeing. So I'm going to raise it really far up, and then I'm going to point it down. This becomes a really long video, but really, this is a very important video. Okay, let it. So, yep, I'm starting to see that over in this corner, over in the back corner, it's a tad lighter. Just a little lighter. And that's telling me that that needs to come up just a skosh. Or, no, down just a skosh, sorry. The lighter the color... Yeah, this is looking really good, actually. So, and it looks pretty good. Same consistency level of purple throughout the print. And I'm pretty happy with that. So that's how you level a bed. That's how I level a bed. I run the little script, run this nice thin bead of purple across the surface of it. And if you really want to go further out than the 90, that's, you can go up to like 120 and have it beat out past this. Generally, I only use, for the things I make, you know, about 100 and 110 of the plate itself. But if you wanted to print like a whole thing, like all these little parts, you might want to make this a little bit bigger and run it, make sure that it's purple all the way through, the same consistency level of whatever filament that you have. But that is how a 3D part gets printed. And we'll look at more complex designs, that's for sure. But this is an initial start. Enjoy.